You have problems you're going to verbalize, or are you going to send me a picture or something?
Let's see here. I will probably send you a picture.
Okay.
1 second.
I have the last picture that you sent me, and we didn't actually get to problem 13.
Oh, yes.
We ended at problem 12.
Yeah, I think I had some different problems to go over, though.
Okay.
We have a test tomorrow.
Okay.
And
that's fine. Absolutely. Whatever you want to go over, I'm willing to go over.
Awesome. Okay. Let's start with. Where are we? All right. I can start with number 2 here. You want me to read it off to you, or the word problems that you have to send you a picture?
Whatever works. Try reading it off. If that doesn't work, let's have you take a picture and send it to me.
Okay, gotcha. So right here, it says the speed of a boat in still water is 16 miles per hour greater than the speed of the current in the river. The boat can travel 48 miles downstream in the same time it takes to travel 32 miles upstream. What is the speed of the boat in still water, and what is the speed of the current?
All right. What's the master formula that covers this problem? What's the general formula? Dirt.
D equals RT.
D equals RT. Dirt. Okay. So, what we're saying is that he traveled at 16 miles per hour for 48 miles.
Okay.
It's 3 hours. So, if I substitute, I got 48 equals, but what is his rate? It's actually his rate plus the rate of the stream times time, which was 3 hours.
Yeah.
So that's the first equation. Second equation, he's coming upstream. Go ahead.
So 48 equals the rate of it upstream plus the rate of it downstream.
No, the 48 equals the rate that he's traveling when he's going downstream. And when you're going downstream, you're going at whatever rate the boat would be going on its own, plus the rate of the stream. Let's say you had a boat that would go 30 miles per hour. But you're in a stream that goes 10 miles an hour. Well, you're going to go 40 miles an hour.
Yeah.
Okay? All right. So, the rate when he's going downstream is the raw rate of the boat, which I'm calling R sub 1, plus the rate of the stream.
Okay, gotcha.
All right. Now, coming upstream. Let me read this for a moment. Is that 32 miles per hour? No. Reread the problem for me.
I have a picture for you.
Well, that'd be better. Send it to my email.
Already did.
Got it?
Number 2.
Uh-huh. All right. I'm glad I had you send me a picture because this is a little different than what I was going to draw. So, the speed of the boat in Stillwater is 16 miles per hour greater than the speed of the current in the river. So that changes things a little bit.
Yeah.
So R sub 1, which is the speed of the boat in Stillwater, is equal to hold on, let me go back and look at this. 16 miles per hour greater than the speed of the currents. All right. That means that we'll call it the speed of the current instead of the speed of the stream.
Okay.
Does this equation make sense?
Well, what does the RC stand for?
The speed of the current. And R sub B stands for the speed of the boat. In other words, if the speed of the boat in Stillwater was X, then they're saying that the speed of the boat in the current is the speed of the current plus 16. Well, that makes the speed of the boat 16. Okay? So, I think I can write the speed of the boat equals 16. Now, let's look back. Boat can travel 48 miles downstream in the same time it takes to travel 32 miles upstream. All right. Yeah, sometimes word problems are better if sent rather than expressed.
Yeah.
So,
I'm sorry, can we just like restart? Because I'm a little lost here.
yeah, I don't blame you. It's a hard problem. Hold on. Before we restart, let me figure it out. Okay? So, the time upstream is equal to the time downstream. The only distance is the distance upstream equals 48. The distance downstream equals 32. You with me?
Yes.
Let me reread the problem, make sure I'm not off. The speed of the boat is 16 miles per hour greater than the speed of the currents. Okay, can travel 48 miles downstream, the same time it takes to travel 32 miles upstream. What's the speed of the boat? What's the speed of the current? Okay. So, Working on the master formula, D equals RT. So what they're saying is that 48 miles equals the speed of the boat plus 16, that's the rate that it's going, times the time. You understand that part?
So
They're going 48 miles downstream, and you got the rate that the boat goes plus 16, because that's the speed of the stream. And you got the time that the trip makes, okay? Now let me write the second equation, because this is a key part to the understanding. This one, they're going upstream. So that's got to be the speed of the boat minus 16 times t, and the t's are the same because the time to go upstream and downstream is the same. So we'll call this the time of the trip. Okay? Now, we should have enough equations. Yeah. Notice if you look at this, you got two equations and two unknowns. The two unknowns are the speed of the boat without current and the time of the trip. Those are the only two unknowns. The second equation is also the speed of the boat and the time of the trip, and they're the same. So, best way to solve this is to make, in the first equation, the time of the trip equals 48 divided by the speed of the boat. And when I say the rate of the boat, I mean in still water. That's what the first equation becomes. Second equation, the time of the trip equals 32 divided by the speed of the boat minus 16. Excuse me. The allergy season.
you all right?
Yeah, I'm fine. 5 sneezes just means it's bigger allergy season. Okay, now what we know is that the time of the trip going upstream is equal to the same time of the trip going downstream. So I can say 48 over the speed of the boat plus 16 equals 32 over R sub B minus 16. That equation only has one unknown in it. That's the rate of the boat. And that's what they're asking about. So that's terrific that we could get it down. You always got to get it down to the same number of equations as you have unknowns. In this case, we got one unknown, one equation.
Yeah.
What's the next step here? To solve for R sub B. Whenever you have a fraction equals another fraction, cross multiply. In other words, if I multiply both sides by r sub b plus 16, and also multiply both sides by r sub b minus 16, this is what I get. 48 times r sub b minus 16 equals 32 times r sub b plus 16. In other words, at this point, we're just into algebra. Nothing else.
Yeah.
We don't care about d equals rt or any of that. We're just trying to solve this equation. Well, what's the next step?
That would make 48 RB minus 768 equals 32 RB plus 512. Yeah, 16.
Next step?
Add the 768 to both sides and subtract the 32 RB.
Okay, so that's 16 r sub b equals 1280.
Yep.
What's r sub b equal to? Hold on. Wow. This Windows 10 has a feature on it that I absolutely hate. Go ahead. What's r sub b equal to?
That would equal 80.
80?
Yeah.
All right. So, let's see if that makes sense. Let's go back. In other words, once you come up with an answer, you always want to make sure that that's a reasonable answer. So they're saying the boat can go 80 miles an hour in still water. And it's 16 miles per hour greater than the speed of the stream. Wow. That right away doesn't seem to make sense. The rate of the boat is 80, and if it's 16 miles an hour greater than the stream, the current, then the current must be 64. Which would make the net, I don't like this answer. We've done something wrong. But it means that if you're going downstream, you're going at 144 miles an hour.
Yeah.
Yeah, that's awfully fast. In other words, that's not a reasonable speed.
It's fast enough.
Hold on, let me have a look at this. The boat can travel 48 miles downstream, which means it's going 16 miles an hour net in 3 hours. All right? No, that doesn't make sense. All right, we've made a mistake here, and I'm not sure where it is. In other words, it can be in any step of the process. The speed of the boat is 16 miles per hour greater than the speed of the current. Well, let's start there. See if we can figure out where our mistake. Well, first of all, let's prove that this isn't correct. Okay? If the speed of the boat is 80 miles per hour and the speed of the current 64, that's 144. It's going to travel 48 miles in 3 hours. Right?
Yeah.
Now let's say it's coming back upstream. Well, now it's going, the rate of the boat is still 80 minus the speed of the current. That's 16. miles per hour net, well, we still have to go the same distance, 32 miles. That would take 2 hours. Actually, 1/2 hour. So, I know our answer isn't correct. Now let's go back to the problem. Alright, we got the speed of the boat equals the speed of the current plus 16. Is that true?
Yeah.
The speed of the boat in still water is 16 miles per hour greater than the speed of the current in the river. Okay, so that's correct. Second, distance equals rate times time. So going downstream, the distance is 48 miles. The rate is not the speed of the boat, but the speed of the boat plus the 16. So,
Yeah.
and times the time of the trip, which is an unknown at this point in time. So this seems to be correct. Now, coming upstream, we can only go 32 miles in the same amount of time, and the rate we're going is the speed of the boat minus the current. The current's still going at 16 miles per hour. So these two equations appear to be correct.
Yeah.
And notice that I still have two variables and two equations. So I should be able to solve this. I obviously have made a mistake in my math. Well, let's go back and restart from where we know we last left off. Both of those equations are correct. And the one thing they're telling me is that the time of the trip was the same. Well, the first equation, the time of the trip equals 48 divided by r sub b plus 16.
Okay.
In the second equation, the time of the trip is equal to 32 divided by r sub b minus 16.
Uh-huh.
And the one thing they told me is the time of the trip is the same. That means this is the same as this. So if I solve that, I should come up with the answer. And that's what I did the first time, but I must have made a math error. In other words, 48 over the speed of the boat plus 16, since the trip times are the same, then that's got to be equal to 32 over r sub b minus 16. Let's solve this equation again. You never know where you made your mistake, unfortunately, when you're doing math. That's why I really highly recommend that you always check along the way. In other words, don't wait till you get to the end of the problem.
Yeah.
Try to make sure that every step is correct. Well, This is what I'm doing is cross multiplying. Understand cross multiplying? Alright. Now I got 48R sub B. What's 48 times 16?
48 times 16.
48 times 16.
768.
That's equal to 32R sub B. What's 32 times 16?
32 times 16 is 512.
Alright. Now if I move my R sub B's to the left, I have 16 R sub B's equals 1280. This looks familiar. What's R sub B? What's 1280 divided by 16?
1280 divided by 16 was 80.
I think yeah, I know you're right. So that's the speed of the boat in still water.
Yeah.
Alright. Well, now hold on. That might work. Let's check it. If the speed of the boat in still water is 80, and they said speed of the boat is 16 miles per hour greater than the speed of the current. That would make the speed of the current 64. That's an awful fast boat and an awful fast current.
Yeah.
I'm not sure what's wrong, Justin.
Yeah, that's kind of...
The only thing I know, I know we're at the half-hour point. I won't keep you much longer. But if the speed of the boat is 80, the speed of the current has got to be 64. And that doesn't fit the math of D equals RT. I don't know what the problem is. This may be one that I have to look at for a little bit before I can figure it out.
Okay.
And looks like you've scheduled lots of sessions next week.
Yeah.
Before I let you go, let's make sure that they're all correct. Got one on Monday, tomorrow at 7.
Yep.
Got another on Wednesday at 7.
Yeah.
Got another on Thursday at 3.
Do you have any on, what, Friday or?
Friday is completely open. You can always find times on Friday. And Saturday and Sunday, as far as that goes.
Gotcha. I might schedule one later.
Help yourself. You're always welcome to schedule if I have an open spot. I don't care if you do 2 hours a day. Wouldn't matter to me, okay? So
Gotcha.
do whatever you feel you need. This problem bothers me. I hate it when I can't figure out a problem correctly, but I will give this some thought, and the next time we talk, I assure you I will have the answer to this.
Cool.
All right. All right, Justin. How's baseball been going lately? You must have got a lot of baseball in the last 3 days with the good weather.
Well, we did, but Friday we were knocked out. Well, the playoff score season was done on Friday.
Oh, okay.
We lost to Weaver's 4-1.
All right. My condolences. You know, if you're playing, that's what it feels like, probably at death. But anyway.
It wasn't just one season for me anyways. So I played 5 games out of 19. And so I didn't have any impact on the fact that we missed the playoffs.
Alright. Well, I guess that makes it feel a little bit better.
Exactly. Yeah. So you think we could try to do number 3 now?
I'm sorry, what?
Do you think we could try to hit up number 3?
Yeah, we're at the end of a half hour. Did you want to go more than a half hour tonight?
Well, I think we scheduled a full hour.
I didn't get that. No, I got a half hour scheduled.
Dad, can I go a full hour?
I'm fine going a full hour.
Yeah, my dad said we can go a full hour. Yeah,
okay.
And I'll go ahead and go on 8 hours.
Yeah, no problem at all. No problem. Okay, let's look at number 3.
All right.
Another distance equals rate time problem. Well, gosh, I hope I don't get this one wrong. Otherwise, I'm going to be really embarrassed. Took 3 times as long to fly 1,800 miles as it took Hamilton to fly 1,200 miles. Find the rates and time of both if Hamilton's speed was 200 miles per hour greater than that of Fabian. Well, this certainly seems straightforward enough. Again, it's distance equals rate times time. Okay, so for Fabian, it's 1,800 miles equals the rate of Fabian, excuse me, meant to write an F, times the time of Fabian. Well, let's just for the moment write that time of Fabian. So that's a true equation. And it took Hamilton 1,200 miles to go the rate of Hamilton, and it's not the time of Fabian, but 3 times longer.
Yeah.
So it's 3 times the time that Fabian took.
I thought Fabian took 3 times as long as Hamilton car, so TF would be 3 times.
You're right. This is 1/3, not 3 times. In other words, Hamilcar took 1/3 of the time, right?
Yeah.
Okay. Now, they give us more information, which we probably need, because notice that what we have here is 3 variables and only 2 equations.
Yeah, exactly.
You can never solve that. You always have to have the same variables as the equations. Well, if Hamil's car speed was 200 miles per hour greater than that of Fabian, that tells you that Hamil's rate is Fabian's rate plus 200 miles per hour, like that. Now we have 3 equations and 3 unknowns. That's all we need to solve it. So, let's try to solve this here. First of all, when you have 3 equations and 3 unknowns, the best thing to try to do is to reduce it to 2 equations and 2 unknowns. It's just easier to solve. 3 equations and 3 unknowns is exponentially harder to solve than 2 equations and 2 unknowns. So I'm going to take this third equation and go back in the other 2, and wherever I see an r sub h, I'm going to substitute that. So now I have 1800 equals r sub f times time of Fabian, and I have 1200 equals, instead of r sub h, r sub h is Fabian's speed plus 200 miles per hour. Is that correct? Times 1/3 t sub f.
Okay.
Now I have 2 equations and 2 unknowns. Well, the best way that I have found for solving for 2 equations and 2 unknowns is to solve each equation the simplest way possible for one of the variables. I'm going to pick that one because that looks to me like the simplest one to isolate. I could isolate r sub f, but t sub f looks easier to isolate. So in the top equation, t sub f equals 1800 divided by r sub f. Got that?
Yes, sir.
And in the bottom equation, t sub f equals 3600, because I'm going to multiply everything by 3, divided by r sub f plus 200. Make sure you see how I got that.
Yeah.
Okay? Now, what they've told me is the times are the same. The time for f is the same as the time for h.
Yeah.
So, I'm going to set 1800 over the rate of f has to equal 3600 over the rate of f plus 200. And notice how now we have 1 equation and 1 unknown. Now we can solve for r sub f. Once we solve for r sub f, everything's going to become clear. Again, cross multiply, because I have a fraction equals a fraction. So I get 1800 r sub f plus 36 with 4 zeros equals 3600 r sub f. I'm going to take the r sub f's to the right side of the equation. And solve it. That is the speed of f. Now, let's look at exactly what they wanted. Find the rates and times. Okay, so let's see. In other words, you always want to check your answer. Does that answer make any sense?
Yeah.
Well, what did I come up with? I'm sorry, I lost it here. I got the speed of Frank is 200 miles per hour, or Fabian, excuse me. So if the rate of Fabian is 200 miles per hour. Find the rate and times if Hamilton's car was 200 miles per hour greater than Fabian's. That means the rate of Hamilton is 400 miles per hour.
Yeah, exactly.
Okay, now, does this make sense? Fabian took 3 times as long to fly 1,800 miles. Well, how long would it take Fabian to fly 1,800 miles at 200 miles an hour?
It would take 9 hours.
Okay. How long would it take Hamilton to go 1,200 miles?
4 hours.
No, 3 hours.
Oh yeah, sorry.
Right? In other words, if you're going 400 miles an hour to go 1,200 miles, you divide it, it's 3 hours. And that verifies our answer, because it says Fabian took 3 times as long to fly, and we got Fabian's rate, or his time, as 9 hours, and we got Hamilton's time as 3 hours. So that confirms that we did it right, and our answers are right. And thank goodness, because I would have hated to miss 2 dirt problems in a row.
Yeah, exactly.
Don't know why I missed the other one. I did it the same way. There's a math error in there. I just didn't spy it. And sometimes that just happens. You can repeat a math error over and over and over, and then sometimes it clicks and you find it, sometimes it doesn't.
Yeah.
So, what next one? I don't see any other dirt problems here.
I have one, number 12. It says, convert 5 minus 12i to polar form.
Okay. What's the number? 5
minus 12i to polar form.
Here's what polar form is. This is polar form. It's called the trigonometric polar form for a complex number. Now, what is R? R is, let's go back and talk about this complex number. The standard form of a complex number is A plus BI. So in this situation, A equals 5, B equals negative 12, correct?
Yes.
Okay, so what R is always the square root of A squared plus B squared. And in this case, that's 13. Square root of 5 squared plus minus 12 squared.
Yeah.
It's a 5, 12, 13 triangle. If you don't recognize that, you should learn to recognize it. It's the second lowest perfect Pythagorean triangle. The 3, 4, 5 is the lowest, and the 5, 12, 13 is the second lowest.
Okay.
So even though we're not really talking about triangles, it's kind of the same thing. In other words, R looks a lot like the hypotenuse of a triangle, right? It's the square root of the sum of the squares of the other side. So R is definitely 13. So I got this much. Now I got to figure out what theta is. Well, that's a little tougher. Theta is equal to the inverse tan of b over a if a is greater than 0. This gets really complicated, but you'll see why. Just like all polar equations, theta is that. Only usually theta is y over x. Usually theta is the inverse tan of y over x. In this case, this is our y, which we call b, and this is our x, which we call a. Doesn't change anything. Theta is still defined the same way. So, in this case, and this is extremely confusing because rarely do we have an equation that's based strictly on the sign of the denominator. This is one case. So, a is positive, so I can cross that out. So we've got the inverse tan of b over a, which is, you have your calculator?
Yes, sir, I do.
Give me the inverse tan of minus 12 over 5. In degrees. You know what? It doesn't matter. Degrees or radians, either one.
My calculator's being really weird.
I can do it if your calculator is not functioning, correct?
Please.
Okay, let me do it on Wolfram Alpha. And I can only advise you to use Wolfram Alpha as much as possible. It's actually better than a calculator, and I'll show you why. It tells you exactly what you put in. So I'm doing arctan of minus 12 divided by 5, correct?
That'd be 12 minus 5.
Ah, divided by 5. Let me find my division sign. But the best thing is that it tells you what I put in. And it's going to in a second. See what it, in other words, if you make a mistake, you spot it immediately. Okay? Now, that gave me it in degrees and radians. Notice the radians is minus 1.176 radians.
Yeah.
But it's also minus 67.38 degrees. So, theta, we'll leave it in degrees, minus,
I think it says like negative 1.176.
that's in radians.
Yeah.
Okay, that's fine. So the answer is going to be that with negative 1.176 plugged in for theta. In other words, that's going to be negative 1.176 radians. That's going to be negative 1.176 radians. And that's our answer. In other words, that is the polar trigonometric representation of this complex number.
What about, I have like later on it says something that says 7 CIS 210 degrees to rectangular form.
That's a different problem altogether.
Can I convert this to CIS?
Yep. You can always go back and forth between these two formats. And here I'm going to show you. We're not done with this problem. Let's check to make sure that we're right. Figure out what that is, multiply it by 13. What do you get? Put your calculator in radians.
13 times
Cosine of minus 1.176 radians.
5.00006.
Now figure out what the sine of negative 1.1 radians is.
Negative 0.923.
Negative what?
0.923.
Sine of minus 1.176. I'm going to do it on Wolfram Alpha because something doesn't make sense. Sine of minus 1.176 should be 12. Question is, does it know that I'm in radians? Because I was just in degrees. Let me type radians there and see if it matters. Minus 0.92. Okay. Minus 0.92. Well, normally, if you do this correctly, when you condense the right side, you get the left side exactly. Okay? So, I feel like I made a mistake because this 5.00006 is 5. The only reason it's not exactly was because we rounded off that answer. Minus 1.176. So that's 5. This should be 12. This number should be 12. Minus 12, excuse me. So let's see if, let's see, what is this in degrees? Let me do it in degrees. That is 180 over pi, right? So, what is the sine of that? Let's do it in degrees. Times 180 divided by pi. not getting 12. Wow. Well, that's all I can tell you, Justin, is that when I do these normally, when you turn that into a number, you get the same thing you started with. That's why the polar representation is the answer. You don't simplify it all the way down, because when you do simplify it all the way down, you get what you started with. And that's not what you want. What you want is the trigonometric polar representation of this complex number. And it's r times cosine of theta plus I sine of theta. And you have to figure out r, which is clearly 13. But theta, I might have made a mistake somehow in theta. Theta is inverse tan of b divided by a. That's a negative. So that's what theta is. I'm going to have to rework this problem, Justin. Apologize again. Man, you're hitting me with some hard stuff here. It so happens that I had a student just the other night that was doing these same kinds of problems. So I'm really familiar with these. I cannot figure out where I've made my mistake though. But this is the thing, that's the general formula. The complex number, which is an A plus BI format, is equal to sum r times cosine of theta plus I sine of theta. And r is the square root of the sum of these squared. So I know r is 13. I can't figure out, it's got to have to do with, I'm going to put these in degrees and work the problem out, see if I don't get 5 minus 12i. Because that's what this should come down to, is 5 minus 12i. It's got to be the same thing. Otherwise, we haven't put it in the proper polar trig format.
Exactly.
So the fact that we're in radians makes it tougher for me to think about. I'm going to go back and redo this problem and put everything in degrees and see if that works. Alright? Alright, Justin. I will talk to you next time.
Awesome. Sounds good.
Talk to you tomorrow. Bye-bye.